Hello everybody. In this lesson we will study the Cartesian coordinate systems and unit vectors. Why is this important? Now most of the time in this course you will be dealing with problems in 2 and 3 dimensions, and therefore it is important for us to be able to represent systems in 2 as well as in 3 dimensions. A Cartesian coordinate systems and unit vectors will help us do just that. But what really is a Cartesian coordinate system? Now, as represented before us, a Cartesian coordinate system is a set of mutually perpendicular axes with a common reference point called the origin. So this right here is our origin. Now, every Cartesian coordinate system consists of 4 important elements. Let me say that again. Every Cartesian coordinate system consists of 4 important elements. The very first is a reference point. Now, we call this reference point the origin. It is where all measurements begin. Now, understand that our choice of origin really is not fixed, but really can be chosen to coincide with some special point on the body or on the system that we are studying. As we deal with problems in physics, you will come to recognize that your choice of origin really is not fixed, but depends on the problem that you are dealing with. And that is very important. That really is very important. Let me illustrate that so that you could get it. Let's say you have John standing there, and you want to measure the position of John with respect. Let's say we have a tree right here. Somebody can choose the tree to be our reference point, so this would be our origin. Or so another person can choose the reference point to be where John is standing. This may be our origin. Now, if you choose the origin to be the tree, it means that John is initially a certain distance, let's say 3 meters from the tree. But if your origin is where John is standing, it means that John is actually initially where at the origin at 0 meters. So your choice of origin really matters, but it is not fixed. It can change depending upon the problem that we are dealing with. That is just what I wanted you to see. Now, the next important property of a Cartesian coordinate system is a set of mutually perpendicular axes. Now, there are 3 of them. You have the x-axis, you have the y-axis, and you have the z-axis. Now, this set of mutually perpendicular axes really sometimes are drawn to align with the physical object. Let me demonstrate what I mean. Let's say that we have a block that is sliding across a surface. Now we can draw our coordinate system. This is our y-axis, this is our x-axis to align with the block. But if the block is sliding up an inclined plane, we can also draw, this is the block sliding up the inclined plane. There are 2 choices that we have here. We can draw the coordinate system to align with the moving object. This is the y-axis, this is the x-axis. Or we can draw the coordinate system to still be perpendicular. This is x prime, this is y prime. Notice something. If you solve this problem in the coordinate system x prime, y prime, it's going to be very complex, and you don't want to get into that. But when you orientate your coordinate system to correspond with the physical object, it makes your problems really easy to solve. So as we deal with different sets of problems in this course, our orientation of our coordinate axis will actually vary from one problem to another. But this is very important. You will see this as we walk through the problems in this course. Now the next point that is really important about a coordinate system is we need to make a choice. We need to choose a sense of direction. For example, we have here this is our y-axis, this is our x-axis. We need to choose which direction is positive and which direction is negative. Naturally, to the right is chosen to be positive, and to the left is chosen to be negative. From bottom to top is chosen to be positive, and downward is chosen to be negative. So if you are moving to the right, your position will be positive. If you are moving from the origin to the left, your position will be negative. So it's critical that we pick a sense of direction. And lastly, we need to choose a set of unit vectors in each direction. But the question is, what is a unit vector? What is a unit vector? A unit vector is any vector with a magnitude of 1. In other words, a unit vector is any vector with a magnitude of 1. In this particular course, you will encounter 3 very important unit vectors. You have I hat, which represent the unit vector in the x direction. You have j hat, which represents the unit vector in the y direction, and k hat, which represents the unit vector in the z direction. These 3 unit vectors, you will encounter them often, and so you need to always remember that I represents the unit vector in the x direction, j represents the unit vector in the y direction, and k represents the unit vector in the z direction. So if we want to represent our unit vector here, we're going to have, this will be I, this will be j, and this is going to be k. And this is very important. So if you write, for example, if you say that the position of an object is 3 meters I, what is this telling you? It means that the person is standing 3 meters in the x direction, in the positive x direction. If the position is, let's say, 2 meters j, it means that the person is standing 2 meters in the positive y direction. So the use of unit vectors really is crucial in physics, and you need to remember that. And lastly, keep in mind that the fact that we have introduced unit vectors automatically gives us a sense of direction, which makes the description of vectors pretty much easily. Let's say that we have, this is our coordinates axis, this is the x-axis, and this is the y-axis, and we have a vector. This is a vector A. You recognize that the vector A is found in the first quadrant. Let's say this angle is theta. This vector A will have a component along the x direction. This is xi. And a component along the y direction. This is ai. Therefore, the vector A can be represented in terms of component as AXI plus AYJ. So we have represented the vector A in terms of its components along the x direction and along the y direction. And in doing so, we can actually decompose or break down the vector into its various components. All right, thank you.